A new study claims the Martian moon Phobos may have been created out of ejected debris blasted out into space when a large asteroid slammed into the red planet soon after it formed. The findings, reported in the Journal of Geophysical Research, adds to a decades-long debate between astronomers about the origins of the tiny Martian moons Phobos and Deimos. The findings are based on a fresh look at 20-year-old data from NASA's Mars Global Surveyor mission, which suggests that the composition of the larger Martian moon Phobos is far more similar to that of the red planet's crust than previously thought. The problem arose because in visible light, both Martian moons look much darker than Mars, leading to the hypothesis that they were captured asteroids. Scientists can study the mineral composition of celestial objects by breaking down the light they reflect into component colours, creating distinctive visual fingerprints. So, by comparing the spectral fingerprints of planetary surfaces to a library of spectra for known materials, scientists can infer the composition of these distant objects. Most of the research into the composition of asteroids has examined their spectra in visible and near-infrared light. And this suggests that Phobos and D-class asteroids look much the same. That is, both their spectra are nearly featureless because they're so dark. D-class asteroids are nearly black as coal because, like coal, they contain carbon. This dark aspect of Phobos led to the hypothesis that the moon is a captured asteroid, one that flew just a little bit too close to Mars and was captured by the red planet's gravity. However, other scientists, looking at the orbital dynamics of the Martian moons, have argued they could not have been captured and must instead have been formed at the same time as Mars, or as the result of a massive collision on the planet during its formative period. In fact, given the inclination and other details of Phobos' orbit, it seems almost impossible that they were captured. So, the study's lead author, Tim Glotch from Stony Brook University in New York, decided to try and solve the issue by observing Phobos using the mid-infrared range. He looked at the heat signatures of Phobos captured in 1998 by an instrument aboard the Mars Global Surveyor. Glotch and colleagues then compared the mid-infrared signature of Phobos to samples of a meteorite that fell to Earth near Tagish Lake in British Columbia, which some scientists have suggested is a fragment of a D-class asteroid. In the lab, they subjected their samples to Phobos-like conditions in cold vacuum, heating them from above and below to simulate the extreme changes in temperature from the sunny to the shady sides of airless objects in space. They found that the Tagish Lake meteorite looked nothing like Phobos at these wavelengths. Instead, mid-infrared Phobos most closely matches the ground-up volcanic basalt rock which comprises much of the Martian crust. Glotch says the findings lead him to believe Phobos might be an agglomeration of debris from the planet and the remains of an impacting object that slammed into Mars early in its history. Phobos is currently orbiting about 6,000 kilometres above the Martian surface and is dropping by about a metre in altitude every 50 years. Large cracks are now visible on the surface of the 11-kilometre wide moon, clear evidence that Phobos is now reaching its Roche limit and is slowly being torn apart by the red planet's gravitational tidal forces. Based on its current rate of degradation, in about 30 to 50 million years' time, Phobos will be no more, having instead been transformed into a ring of dusty, rocky debris orbiting Mars.